Hi everyone, today we're going to talk about graphing our parent functions of our trigonometric graphs, the graphs of cosine and sine. On page 225, we see the graph here of in radian format, and we want to think about for some of these graphs, for instance, if we think about pi over 4, we know that that output value is the square root of 2 over 2, which is approximately 0.707. So as we start graphing, when we think about the signs of our graphs, we have sine of 0, which is 0, sine of pi over 4, which again is about 0.707, sine of pi over 2 is 1, 3 pi over 4 is square root of 2 over 2, so about 7.707, down to 0 at sine of pi, and then down to the negative direction, negative 0.707, negative 1, negative square root of 2 over 2, and all the way to 2 pi, which sine has 0. And as we see, this pattern is going to continue because we know about this periodic nature, both in the positive direction, or if we went to the left on our graph in the negative direction, we would also see that sketch of our features. So again, what this shows us is our parent function of sine. And sine has a domain of all real numbers, as well as a range that goes from -1 to +1, including both values. The amplitude for sine's parent function is 1, and again, this is going to repeat itself every 2 pi. We don't see any vertical asymptotes this time, and our minimum, if we're looking just from the range from 0 to 2 pi, is going to come down here at 3 pi over 2. We would have a minimum value of -1 at x equals 3 pi over 2. Now if we move on to the next page, at the top of page 326, they ask us to complete the table here. So we have the sine of -3 pi over 2, which is going to be +1. Sine at pi over 2 is +1. Sine at 5 pi over 2 is also +1. And we see that here all over the graph, each of these having that max point of 1 on this. And again, what we know about these is on the unit circle, these would all be considered coterminal values. And we know if we look at this graph, when it comes to the symmetry of it, if we try to fold this graph over the y-axis, we notice it is not going to fold onto itself. So we would say that when it comes to the symmetry of the y-axis, it is not going to fold on top of itself. However, if we think about the symmetry to the origin, if we flipped this graph upside down, it would in fact look the exact same. So because this does have symmetry to the origin, we would call this an odd function as a result. So sine is going to be an odd function like we talked about in our previous units. So again, that kind of connects to that next question. This is going to be odd because of that symmetry in there. Now, as we move on then to number 2, this time we are talking about our graph of cosine of x. So again, cosine, if we think about cosine of 0, that's 1, and then we go down to 0.707. Our cosine at pi over 2 is 0, negative square root of 2 over 2, so negative 0.707, -1, and then we start moving this back up in that positive direction. So here is from 0 to 2 pi on our cosine graph. And again, like the others, again, this is going to keep continuing the pattern all the way down. If we keep going beyond our normal graph here, and then as well as into the other direction as well. Now, some information about cosine. Again, that domain, like sine, is all real numbers. Our range again is going to go from -1 to 1. Amplitude is 1. Period is 2 pi. So we see a lot of things in common on those key features between both of the graph. And if we think about a period in which this is increasing from 0 to 2 pi, so this red portion of our graph, we are increasing from the x value of pi all the way until we get to 2 pi, and then it starts decreasing again. Now this time when we talk about symmetry, our graph is going to have symmetry to that y-axis. It is not, however, going to be odd. So when we talk about the symmetry, we are going to say we are symmetric to the y-axis. So cosine is an even function. And down for part E, again, if we notice what is the relationship between these two graphs, well, if we look at our cosine and our sine graph, even if we took a moment to graph them. So we have sine of x, sine of x and cosine of x. Again, if we do a little zoom trick, so zoom option 7, and we look at these two graphs, they essentially are very similar. However, they look like they are horizontal shifts of one another. But otherwise, it has the same amplitude, same period. Otherwise, they look like they are horizontal shifts of each other. Right. Now, as we look onto the next page, then, we want to start talking about, again, some of these little graphs here of our parent function. So we see for sine of x, when we talk about the parent function, its period, again, is 2 pi. So if we divide our 2 pi graph by 4 to figure out the scale, what we're going to notice is we are going up by 0.5 or 1/2 pi each time. And that makes sense based on our unit circle values at each axis to kind of include this each time. And sine is always going to start at 0, go up, down. Think about the y values at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Again, all those y values, those output values for that graph. Cosine is again going to have the exact same period and overall scale. It again repeats by the time it gets to 2 pi. However, cosine starts at the positive amplitude value there of 1 and then makes its one whole cycle all the way around. And again, think about those x values on the coordinates. Cannot stress to you enough how important it is to know these two basic parent functions, because a lot of our transformations upcoming are going to be based off of those two. Well, what do we mean exactly? If we look at example A here, hey, we start seeing some of these parameters changing our graph. So notice we have the parent function, sine of x, and then g of x is going to be 2 sine of x. So what's going to happen is with that 2 sine of x, that 2 is causing our graph to be stretched further than it was before. So notice it's kind of doubling that value of our max or our min on these for that vertical stretch. So again, we see it's twice that size on that. Now down below, when we are in charge, what we're noticing this time is that plus 2 is coming on the outside there of the cosine function. So we've talked about this before, whether it be with transformations, whether it be when we talked about initial features of our periodic graphs. But what this is going to do is vertically shift our graph up 2 units. So essentially what's going to happen is we still have our traditional cosine graph with an amplitude of 1. However, it's going to start up at 3 as opposed to the normal graph here. It goes down, down 1 again, back up, and then back up again. So we see that one full revolution. versus our parent function of cosine that looked like this. Again, our period, we are repeating by 2 pi. Each little piece goes up by pi over 2. And again, we want to see at least one cycle of this. However, we can also expand this out because we know the cycle keeps repeating in either direction, even if we went towards the negative pi over 2 direction. And then same thing with our normal parent function as well, just so we can compare those two graphs to each other. And again, the description that we would say g of x is a vertical translation up 2 units. Now on the next page, we see that we have the cosine. And again, if we think about cosine of 0, that's 1. Cosine of pi over 4, that's square root of 2 over 2. Now, if we shift everything on this graph, x minus pi over 4, everything is shifting to the right, essentially. So what was, in this case, if we take that cosine, we'd have square root of 2 over 2. However, this becomes 1. And as we look at this, we notice that this is still shifting to the right 1. And if we had filled out the rest of this chart, this is moving to the right 1, to the right 1. Everything is shifting to the right 1 unit. So again, if we think about our normal parent function here, okay, this is our normal parent function graph of cosine. What's going to happen on this one is everything is going to end up shifting to the right 1 unit. So instead of starting at 0, we're doing pi over 4, not pi over 2. If we shift everything over, this is going to be at pi over 4 now. This shifts over halfway, shifts halfway, shift, shift again. So all of these are moving pi over 4 to the right. And again, we would call this a horizontal, or sometimes they call that with trig a phase shift, right pi over 4. Now, our next piece then for number 5 is noticing again something inside that parentheses again. This time we have plus pi over 2. So this is going to shift our graph to the left pi over 2. So again, we call this either our horizontal, or with periodics, they like to call this a phase shift, which is the same thing as a horizontal shift. And this time our graph is going to move to the left pi over 2. So everything else with our sine graph otherwise, because again we're comparing sine, is the same, just it's going to repeat in 2 pi's time. It just would finish its cycle this time because everything shifted to the left. All right, now this leads us to that overall big idea when it comes to the parameters on our feature. So we have something here that definitely want to jot down. First and foremost, parameter A affects the amplitude. It is going to be a reflection over the x-axis. If it's negated, it would be a vertical stretch or a vertical shrink, depending on how big A is. Parameter B, notice, is not on there right now. That's going to be what we focus on tomorrow, so kind of ignore that for right now. The other two, however, that we talked about was the phase shift. So notice that is going to be parameter C, that shift left or right. And then finally, our shift up or down is going to be parameter D. Remember, with the left and right, it's a little opposite. Plus means left, minus means right. Verticals, plus means up, minus means down. Thanks everyone for watching. We will definitely work more with these in class.